Okay, so let's continue. So as I said, there are many methods to calculate this summation. You see, it is summation of x of k times h of n minus k. But the easiest method is called tabular method. So you put x of n this and x of n vertically. So the first step, step one, is multiplication. Okay, so multiply 2 times 0, we get what? We get 0. 2 times 2, 2. 2 times 0, 0. 2 times minus 0.5, it will be minus 1. Am I right? I am multiplying the first h of n here with all samples of x of n here. Next, the next sample h of n is 1. Before you multiply, shift by 1. Why? There is a shift operation. As you can see in the formula, n is shifted by k. K can be 1, 2, up to infinity. Okay, so h will be shifted by k factor. So then you multiply, after shifting h, multiply it with x. X is our input. Then 1 times 0, it will be 0. 1 times 2, it will be 2. 1 times 0 again, 0. 1 times minus 0.5, it will be minus 0.5. Okay. Before you go to the next multiplication, again shift h by 1, 2 more, because k increases, right? Then multiply, it is 0. The next sample is 0. So 0 multiplied by 0, it will be 0. 0 multiplied by 2, 0. 0 multiplied by 0, and again we have 0. Next, shift by 3. Okay, here no shift, k will be 0. In the first case, shifting will be 0. Okay, I mean, you said 2 times 2, 4. Let me check. 2 times, very good, very good. Sorry, 2 times 0, 0. 2 times 2, it will be 4. You are right. You're right. Don't make mistake in your exam. Like this. So 2 times 2 will be 4. 2 times 0. Okay. Is there any other mistake? I think I'm right. So minus 3 times 0, it will be 0. Minus 3 times 2, minus 6. Minus 3 times 0 again, 0. Minus 3 times 0.5, it will be positive 1.5. Alright, now it's finished. If there is another sample, you have to continue. Shift by 4, shift by 5, and so on. After you complete this, the next step is in your formula, you see, you have to add. Okay? Shift, multiply, then you have to finally add summation in order to get your output. So where is the result? The result is here. This box is our result. All right? This box is the result. These are the inputs. These are the impulse response, h of n. These are the results. Then you have to add the result only. Here in this column, we have only 0. In this column, we have 4 and 0, 4 plus 0, 4. In this column, 0 plus 2 plus 0, it will be 2. Here in this column, minus 1, the rest 0. How about here? Minus 6.5. Here we have 0, and finally 1.5. That is our output, y of n. Okay, always if you put it like this, you will not get the full marks. To get the full mark, you have to show where is the arrow for the output. So in the input case, the arrow is in the input case, as you can see here, where is the arrow? Here. So how many samples to the left? Only one sample. So to the left, we have one sample for input. For impulse, the arrow is here. How many samples to the left? 2 samples. We have to add this. So 1 plus 2, it will be 3 samples. So in the output, you jump 3 samples and you put the arrow. To the left, we need to have 3 samples, 0 for 2. Okay, that's how we determine the position of the arrow in the output. Any question? Is it clear? Okay. So far, we have seen chapter 2 and chapter 1. We revised chapter 1 and chapter 2. Okay. So chapter 2, basic elementary signals. We have seen here. Basic operation on signals, question number 2, and question number 3, convolution sum. Okay, that's from chapter 2. Next chapter is Z transform. Next chapter that will be included in your exam is Z transform. Okay, so first question from chapter 3. What is the advantage of tools like Z transform, Fourier transform, DFT, FFT, fast Fourier transform, discrete time Fourier transform? In DSP, there are 2 methods. Time domain method, like convolution sum. What we have studied here is time domain method. You can see output is a function of what? As a function of time. So convolution sum, this is time domain analysis. But in chapter 3, we use transform domain analysis, Z transform, DFT, FFT, very important mathematical tools. In DSP, they are Z transform, discrete time Fourier transform, or discrete Fourier transform, and special algorithm called fast Fourier transform. So very important, this Z transform and DFT. But in this course, we have discussed only Z transform. We didn't discuss DTF, discrete time flow transform, because it is very important as telecom or electrical engineers. These days, FFT and DFT is basic design tool, mathematical tool to understand these modern systems. Okay, so my plan is I will make a video lecture on, very nice video lecture on DTF or FFT, but it's not included in your exam. But I will make this video and I will post it for you. Why? Because it is very important. But we have already discussed Z transform, right? Now question number 1 says, why these transforms are so important in the modern engineering world. You can mention many advantages, but let's list some of the advantages. First, these are very easy to implement it in software production. To use your computer, to use signal processing in your computer, to write a program, to develop a program. Time domain is a little bit tedious, difficult, but these are easy to use it in the computer. Okay, why? Because these days we have powerful computers. Computers are very important signal analysis tool. So to use your computer, which method is easy? These transform methods are very much easy compared with time domain. Second, when you compare with time domain, analysis and design of digital systems easy when you are working on the transform domain. Okay, easy in terms of analysis and design. Another one, most engineering systems, both electrical and telecom systems, they use not time, but the most important parameter is frequency. You know that, right? In every system design, frequency is very important parameter compared with time. When you talk about signal, the first thing you have to know is what is the frequency of this signal? What's the frequency of this noise, interference? So frequency is very important parameter. These systems, these transforms, they use frequency, not time. Okay? They are used frequency. So you can mention many more, but these are the 3 most important advantages of this transform domain analysis. First, it's very easy for software implementation, very easy to use computers in transform domain. Second, analysis design will be easy compared with time domain. And finally, these transform domains, they use frequency instead of time. Okay. But in this chapter, we have discussed only the transform method. We didn't discuss the Fourier one, discrete time Fourier. But I'm telling you, and you will see it in the future, these are very important. So I will make a video, a lecture video, and I will post it for you. But it's not included in the exam. Not only this DFT, chapter 4 also, the design realization also we will discuss, but it's not included in the exam. So your exam is up to Z transform. Chapter 1, chapter 2, chapter 3, only Z transform. So let's see one example from Z transform. Here, so Z transform, as you can see here, you can transform time domain signal, which is a function of time, into a frequency domain, complex frequency domain, x of z. Okay, z is a variable. In this case, it is time variable, and Z is a complex frequency variable. Okay, that's why we say it is depends on frequency. So how you are going to transform your signal from x of n to x of z? This is the Z transform definition formula. Okay. Why we need to transform? Here you see I explained the advantage. Okay, for computer implementation, for simplicity, and to convert time into frequency. So that's why we need to determine the transform of the x of n given here. Okay, so let's see. Solution. Always start from the definition. X of z is equal to summation n from minus infinity up to infinity x of n, the given signal, the waveform in time domain, times z is a variable, the power of minus n. This is the definition of Z transform. Okay, in your exam, please show the steps. I'm not giving marks for the final exam. I will give marks for each of the steps. Okay, so time here you see from minus infinity up to infinity, but our signal, how many samples? Only 3 samples. So what is the time range? The arrow is 0. So our signal, 1 sample to the left, which is -1, 1 sample to the right, which is +1. So what is the time range? From -1 up to 1. So n, in the definition, you see it is from -50 up to infinity. But here, our signal has value from -1 up to +1 only. All the other samples are 0, so we don't need to add. Now, x of n, z the power of minus n. Okay, then substitute n values. What do you get? When n is -1, x of -1, z the power of minus, it will be +1, right? Because here is the formula is minus. Here is also -1, minus of minus will be positive. Plus, because this is summation, what is the next n? N is 0. X of 0, z the power of -0 means 0, right? Plus x of, what is the next value? X of +1, z the power of 1. When n is 1, it will be -1. Okay. Then what is x of -1 from the given? X of -1 is +1. 1 times z the power of 1 is z, plus what is x of 0? X of 0 is 0, so this will be 0. What is x of 1? For -1. Okay, so -1, z the power of -1. Okay, so this will be z minus z the power of -1. This is our Z transform. We transform this sequence, discrete time signal, from time domain to frequency domain. What we call it, x of Z. Okay. Any question?